problem involving an even power of secant, namely secant to the fourth of 2t. Well, what we'd like to have in there is tangent, because the derivative of the tangent function is secant squared. So how we want to think about this then is as secant squared of 2t times secant squared of 2t. Now, why do we do that? Well, now we can apply this identity here to one of those secant squares. So secant squared of x is 1 plus tangent squared of x. So that means that secant squared of 2t will equal 1 plus tangent squared of 2t. So now we have the thing we're integrating is secant squared of 2t times 1 plus tangent squared of 2t. And now we're ready to do a u substitution. We can let u equal tangent of 2t. Then du will equal secant squared of 2t times, because of the chain rule, 2 dt. And let's see what happens when we make our substitution. Well, here we have 1 plus u squared. What remains here is secant squared of 2t dt. And secant squared of 2t dt is 1/2 du. So this now becomes the integral of 1/2 times the quantity 1 plus u squared. And now this is something that we can integrate. We can put the 1/2 first out front, so we'll have 1/2 times the integral of 1 plus u squared du, and this becomes 1/2 times u, the antiderivative of 1 with respect to u, plus u cubed times 1/3, plus a constant of integration. And now we're almost done. We need to substitute back in terms of the original variable. And recall that earlier we had set u equal to tangent of 2t. So now we can make that substitution, and we'll have 1/2 times tangent of 2t plus 1/3 tangent of 2t cubed, plus our constant of integration. Now let's look at an example that involves an even power of the tangent function, namely tangent to the fourth of 2x. So what we want to do is introduce some secant powers into this problem. So we're going to think about this as the integral of tangent squared of 2x times tangent squared of 2x. Now, why would we do that? Well, because we have an identity here that relates secant squared and tangent squared. And this tells us that we can replace tangent squared of x with secant squared of x minus 1. So that means that we can replace tangent squared of 2x by secant squared of 2x minus 1. So now let's do that. So we'll have the integral of tangent squared of 2x secant squared of 2x minus 1. And now let's split this up into pieces by distributing the tangent squared of 2x. So we'll be integrating tangent squared of 2x times secant squared of 2x. That will be one integral. And then we'll be integrating tangent squared of 2x is another integral. Now, looking at this first integral here, what we can see is that we have tangent, a power of tangent, and secant squared, which means we can do a u substitution and let u equal tangent of 2x. So for this first integral here, we're going to let u equal tangent of 2x. Then du is going to be secant squared of 2x times, because of the chain rule, 2 dx. So now let's make that substitution here. So we'll have the integral of u squared, And what we have left here, secant squared of 2x, well, secant squared of 2x is going to be 1/2 du. So we can replace this with 1/2 du. And now for the second integral here, we don't know an antiderivative for tangent squared, but we do know one for secant squared. So let's use our identity again to rewrite that tangent squared of 2x as secant squared of 2x minus 1. We'll have minus the integral of secant squared of 2x minus 1. And now we're ready to solve these integrals. Over here, this becomes 1/2 times 1/3 u cubed. And over here, well, the antiderivative of secant squared of 2x is 1/2 tangent of 2x. Just doing a quick u substitution in our heads. And the integral here of the 1 is going to be an x, and it will be plus x, because we have the minus sign here and the minus sign here, plus a constant of integration. And our last step then is to rewrite everything in terms of the original variable. So writing our final result up here, what we'll have is 1/6, and u, remember, was tangent of 2x, so we'll have tangent of 2x cubed minus 1/2 tangent of 2x plus x, plus our constant of integration as our final answer.